Hey, all right, welcome to the show. Thanks so much for joining. It's me, John Park, and it's time for John Park's Workshop. Sorry, we had a slight technical delay there for a moment, so you got to hear the weird chaff song one more time, most of the way through. And I want to say hello to the people over in our YouTube chat. Thanks for joining us. Hi, Dave Odessa. Hey, Quinman16 and Modern Magician. Howdy. Thanks for stopping by. And for people who are wondering where the other chats are, if you're over on Facebook or on Twitch or some other place, Periscope, does that exist? LinkedIn Learning? I don't know. But if you're there and there's not a lot of chat evident, then head on over to this place. This is our Discord chat, and you can head over to adafruit.it/Discord. Look for the live broadcast chat channel. That's this one right here. And I love Thursday. What a concept. Thanks for throwing that in there. That made my day, Andy. I love that. I got to rewatch that. So, what's happening here? Hi, Blitz City DIY. Thanks for stopping by. Hope you're feeling well. Andy Calloway, yes, Jim Hendrickson, Thin Man. Thanks everyone for hopping on over. And yes, Lars is. What's Lars doing over there on the Meowzic? We're gonna get inside that Meowzic. I'm excited about this one too. It's very cool. So, let's see. First of all, I'll give you a little delicious coupon code to use over in the store. So, if you head over to Adafruit and you buy some cool stuff, you can build some great projects. And we get to keep the lights on here, which is awesome. That's how we get paid. But we want you to get a little discount. So, if you use Happy Day, Happy-Day, today, this very day, you will get 10% off in the store. on your entire order of physical stuff. It won't work on gift certificates or software or gift subscriptions, gift certificates, subscriptions, software. Those are the 3 or 90 things. I can never say those words together. I got to come up with, I got to practice, like the right order that works for me. The one I tend towards doesn't work for me. But that's not the point. The point is you can get 10% off over in the store. And if you head over there, if you just jump on over to, let's see, where'd this place go? This is the Adafruit store right here. Well, let me make that a little skinnier so that it fits. Fit thing. Almost. And if you jump over to this little hamburger element up at the top, I call that the hamburger, I think a lot of people do. If you click on that hamburger, that's a little quick navigation thing. That's for when your screen is narrow-ish. That'll pop up. And you can go to new products right there. You can see some of the cool new products that came out since the last time. I'm excited about these. There's the Pimoroni Pico VGA and DVI demo bases. I just started working with, I'm building a little VGA video synthesizer, video generator, test signal generator kind of thing. And so I've got a whole VGA workflow that I'm working on. So it's kind of cool to think about doing some VGA with the Pico. What else? We've got this little camera breakout. A few of these came out. I think we just had a small number of them, but there'll be lots more. And Lady Ada's getting into cameras. So this was the OV5640 camera breakout with a 120-degree lens on it in this sort of standardish 9x2 breakout format for the pins. Also this Adafruit floppy feather wing. I got to get one of these. I want to play around with all of the floppy action. I got a box of discs. Where did I put them? I hid them around here somewhere really good that I can't find. But I got a nice box of floppy disks, and I got to get a matching drive so I can try to play around with those. This one's coming soon too, this Metro M7 with airlift. That's a Metro with a very advanced chip on it that'll be coming. And more and more and more. But if you want to get any of those things or anything else really that your heart desires in the Adafruit store and you want to get a little discount on that, then type that in, happy day, happy-day. That'll get you your 10% off today in the store. Let's see, on Tuesdays I've got my other show, which is the Product Pick Show, and on that I get to play around with some new thing and give you a huge discount on it. We had this one for a 50% off discount this week, which was great. It was like $7 and something or other for a feather board that happens to have an RP2040 chip on it, and it's got all of those pins for driving NeoPixels. In fact, I've got mine hooked up. You can just see a bit of it right there, that demo that I showed. It's actually also glowing some light over there. I want to find a cool way to display that. But here's a little recap from that episode, just 2 days. Feather RP2040 Scorpio. It's an 8-channel NeoPixel drive-in feather. We can use the NeoPixel 8 library inside of Arduino and in CircuitPython to animate NeoPixel LEDs, up to 8 strips or rings of them. It's all using a PIO state machine. It really leaves the other processing free for you to do other stuff on the board, such as read inputs or write to displays. Feather Scorpio there, and that has the right angle headers. And then I'm using one of these IDC ribbon cables to breakouts for IDC. And this one is keyed, so you can't put it in wrong. So all the white wires there are the data lines going into all of the 8 NeoPixel strips. And then all the black wires there are connected to grounds. The power side of the NeoPixel strips broken out to snap connectors here. And then I have this running to one of our little DC breakouts. Feather RP2040 Scorpio. Yes, it was. So I hope if you wanted some of those, you got some of those. Let's see, what else is up? Actually, I just threw this note out there. If anyone can let me know if the frame rate seems healthier today. I made just one, proper scientific method. I made one change to my setup on the frame rate that I'm sending. I was sending 60 frames a second up to Restream. I dropped it to 30. I'm curious if I was clogging up the bandwidth there with too many frames and it was wigging things out. So I'm waving my hands because that's usually a good test of frame rate, right? And I don't want to try to monitor that. So let me know what you think about the frame rate today. What else? Oh, Blitz says frame rate is smooth. That's good. Thank you. Thanks for the update. Okay. What else is going on here? Hey, this is a good chance to do a CircuitPython parsec. And for this one, actually, the smoother frame rate, which I'm getting multiple reports in that it is smoother, this will be helpful. Actually help with seeing what's what. So check it out. All right. Of course, I spoke too soon because I just broke the demo, didn't I? All right, let's see if I can restart. There we go. All right. Hopefully that'll stay running. You can see that. So for the CircuitPython parsec today, I wanted to show you how to iterate forward through a loop and then back through a loop, and in this case to do some cool ASCII graphics, but you could apply this to anything, particularly things like NeoPixel animations is a good one, sound things. Anytime you want to create an increase and a decrease running back and forth, this will help, and it's quite simple. So all I'm importing library-wise is the time library, so I can put little pauses, I can adjust my intervals. Then I have an integer variable called len for length of 10. So that's how many times I'm going to loop forward and then how many times I'm going to loop backward. My interval is the time period, so that's how quickly this happens. And then here you can see in my main loop, I have essentially the same type of for loop repeated twice. First I say for I in the range of my length, in this case 10, I'm going to print a space multiplied by I. So at first, I is going to be 0, then 1, then 2, then 3, then 4, all the way up through the end of the length of the thing. So I'm just adding spaces, and then I'm also printing this little ASCII art of a dot, dot, and a bracket. I pause a little bit between each one so it doesn't zip by too fast. So that gives us the increase, and we get out to the edge of that sort of saw wave we see. Then we're working our way backwards. We say for, again, I in the range of that length of 10. We're going to print space times the length minus I. So initially, I is 0, so it's just that length. Then the next time through, we're going to be increasing I, so we're going to take length and subtract 1 from it, 2, 3, 4, 5, 6, 7, 8, 9, all the way through until we reach the end and then loop back through. And so this is one way you can really clearly and easily loop forward and backward through a range. And that is your CircuitPython parsec. All right. Hopefully that stayed smooth the whole time. I think the encoding is not making the ASCII art scroll very smoothly, is what Todd just said. So that's too bad. But you'll see a different effect locally as far as how wiggly and fun this looks. But the notion of it incrementing slowly outward might be a little easier to see. So here you can see I'll adjust this just for fun. I'm going to say, give me an interval of 0.1. So that's going to be slower. That'll probably be a little easier for the video encoder to deal with. And this doesn't have to be just things like the ASCII artwork moving out by spaces. We can also do something like, let me see, I should be able to actually show the value of I at the end of each of those. So you'll see it go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can see the value of I keeps increasing, but it's that length minus I. So if I put that here, length minus I, we should see our, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 on the way back. I thought of using this for something like tempo of a drum machine or an LFO to adjust a volume or something like that. There's a lot you can do with it, but I thought this might actually look clearer than trying to do it with audio. And we will be doing some audio stuff. So that was our visual stuff today. All right, let's see. So let me go back to regular view there. I'm going to unplug this Metro. I'm glad that behaved, because for a moment there it was looking like the Metro didn't want to send over to my serial, my REPL, which can be a bummer. Okay, let's see. I think we'll jump right to it. So this is what we're going to be talking about here today. This is the Meowzic toy piano, or cat piano, Meowzic. This has been around for a few years at Target. It's hard to find it anywhere else, or you'll see it marked up. So it must be a Target exclusive. It's a company called B Toys. They have a bunch of cool stuff on the shelves at Target. And then this is like $27 or something for this cat keyboard. It's a kid's toy, priced like one. You can pay double that if you try to go to Amazon or eBay or other places, from what I can tell, unless you maybe get a used one or something. But real cheap at Target, less than $30. And it is the only toy piano I've ever seen where the keys have a shape to them. The length of the keys has been completely manufactured custom just for the purposes of this design, which is fantastic. I love it. So it's a simple electronic synthesizer. It plays back some samples that are pitched, these meow sounds, as well as some other, there's piano sound, bells, organ. And it also has a little microphone input, and it can play back, it can record and play back some short passages. You can adjust the tempo of that. You can also adjust some different rhythms that are built into it, and then there's some canned songs in it. So I wanted to take a look at this one, and I know that people have done some modifications on it before. I think people have circuit bent it, and I think maybe someone did a limited version of a MIDI, or not MIDI, but like a serial output, so they could just read it like buttons on an Arduino, I think it was. And then I've seen one that was circuit bent and had audio, line audio output. So one idea I have with this is that a lot of those circuit bent ones are kind of focused on more adult type of players who want to do some cool noise art, glitch art, circuit bent stuff, and not just noise. It can be very musical. But in the vein of the kid hackers and toys for hacking on in the home for infants, kind of like the See and Say that I worked on. One thing I wanted to do is just see if by adding an audio output to it, we can improve the quality of the sound that comes out of it. And one reason I say that is that there are a lot of instruments that I've run across in electronic music, and an electric guitar is actually kind of a great example of this, where the instrument itself doesn't sound like much until you add some processing and some effects. And that can be anything from just distortion of a cabinet and overdrive to any kinds of effects pedals that you want. So my idea is, this could be for an adult, this could also be for a kid. It is a lot more pleasant to play this thing once you put a little bit of delay or reverb or both on it. So what I want to do is show you what it's like, just give you a tour of it on its own. Then I'll show you the guts of it that we care about if we're going to try to get a switchable audio output properly and safely, so that we can switch between the built-in speaker versus a 1/4-inch jack that we can plug into other audio gear like a guitar pedal. You know, if you think of a lot of new parents have little kids, they get this thing. A lot of new parents still have their guitars and pedals and amps around, so why not marry the two together? I don't know if Phil and Lamore have amps and pedals, but maybe they do. So let's jump over here, and I will take you on a little tour of this Meowzic, and so hopefully you can hear the little speaker on it well enough to get an idea of what it does, and then I will dive into the modified version. So this one actually, right now, I have some a couple little leads soldered to it internally, but at the moment, none of that changes anything. So I basically, it's basically untouched. I have the output from the audio card on here running to its speaker. So if I turn it on, I'll turn the volume all the way up. So you can hear it beeping there. It's got a little digital volume. And I'm just going to lower my lav mic down here so you can hear this. So here's piano sound. Even has its own little bit of distortion there on some pitches, just I think from harmonic feedback of the resonant plastic there. This plays 2 tones at once, maximum. So I'm trying to play all 3, but it only is playing the first 2 I hit. So that's the piano sound. There's these bells. I'm skipping meow because it is the best, so we'll hit that last. Organ actually has some sustain. So you can hear it kind of peaks up and then comes back down. You know what? I'm just going to pop open the Discord chat so I can see if anyone has any issues with hearing this. Hopefully you can hear it well enough. So there's the organ. And banjo, which is nice and plucky. There is not an octave switch on this. So one mod I've seen people do is add a giant pitch knob that'll like drop it down an octave or 2 and raise it up. And it's I don't know if the pitch tracks that well once you start doing that, or if it's a more of a adding resistance circuit bend kind of thing. Kind of sounded like a circuit bend thing. There's a YouTuber called Simon the Magpie who's got the best example of a circuit bent one. He did one with just the audio output like I'm going to do, and then there was someone called House Cat who does toy modifications, instrument mods and stuff, who did one with a LFO and some other mod, I forget what it was, as well as pitch bending. So that's banjo. It's got these built-in drums. So that's apparently a a rock. Here's blues, samba, techno, kind of cool, and disco. So you can increase and decrease the tempo. And then I'm going to put the lav here for a second. You can also hit stop, this nose button for stop. I don't know why they made it beep when you hit stop, but I guess why not. You can play back, oh, here, let me give you the cat sound. I forgot to do that. So here's meow, and they preview the sounds when you press these, which is kind of neat. Which is great. You can, here's the full range. Lowest, highest. You can record. So if I hit record, hit record again to stop, and now I can play that back. Put that back on screen. It has a really terrible microphone with a very nice retractable cable mechanism on it. Test, test, test. Test, 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 test. It just peaks out immediately. It always sounds like garbage. So the only thing interesting about it I found was feedback you can get using it with your amplifier. So maybe we'll explore that. I may also add a switch to cut the mic. It's always active. So I might add a switch to cut that so that you don't have to hear that feedback once you get it going through your amplifier. And then it's got some built-in songs, which I won't play. On-off switch there. So now let's take a look inside. I've already removed the massive pile of screws. By the way, it has a really, really nice carrying handle. Nice and easy to carry. I'm not sure why they did that, but that's great. Carry that thing around. I guess kids might want to carry that around and have small hands. It might be a nice way to carry it. So nice big rubber pads for the feet, so it doesn't slide around. 6 AA batteries in here. I can leave that closed, and I will. In fact, let me tighten that up because it's a little loose. I don't want them coming out. And here's the giant pile of screws that came out of there to open this up. I didn't count them, but it's like 21 screws or something like that. And then it's slightly snap fit as well. Besides having all those screws, the case, you kind of have to get a finger or a guitar pick or something under there. So I was looking at the comments. DJ Devon, I don't think it acts vocoder-like. I don't think playing pitches actually influences your sung vocal. It's so hard to tell if that's what it's doing that I don't think it is, but it's kind of funny. I couldn't exactly tell. So here we have on the bottom, we've just got 2 things really. The battery pack, and you can see this is, actually it's 4 batteries, 4 AA's, and there's a diode, protection diode here, probably Schottky. And those power runs to the on-off switch, which is over here, and then ground runs to the main board and then is distributed elsewhere. And then the other thing on this side is the microphone. So you can see it's got this really great, well-designed, well-engineered, retractable locking cable. You can press that and then release it. And of course, imagine young kids, I think this is listed as like ages 5 and older or something, will want to pull that out and then just press this and suck it back in all day long. So it's got to be pretty robust to deal with that. Microphone runs to this board right here. And I'll zoom in just a little bit and then we'll get closer. Try to get that focus. There we go. So the mic cable goes in here. It has 2 wires coming from it, I believe, and then it's got some strain relief hot glue. You can see most of the wiring has hot glue strain relief, which is a good idea. And I have not, I think we will before the end of the show, taken everything apart to flip it upside down. One thing I am interested in, and I think you can see it here. So this is, let me just see if I can boost the brightness here 1 second. That's a little better. Too bright. There we go. So this here looks like a little PCB for all of the key presses. And you can see the little telltale rubber nubs there, these little kind of white rubber nubs that have been pulled through. Those are an indicator that this is going to be like a video game controller type of rubber dome or elastomer dome with a little capacitive or conductive pill in the bottom, and then there will be some copper traces like this that get closed when each key presses. I also love that the sort of base support that all of the keyboard lives on is also kind of a smile, kind of a Cheshire Cat looking smile there, which is great. So we have a few button, little ribbon cables running for buttons. I think this one here is one of the canned songs, and I think that runs into this ribbon, along with maybe some of the keys. I'm not sure. Some more keys. There's probably a matrix that it's reading, because this is what, like 8, 1, 2, 3, 4, 5, 6, 7, 8. I think there's 8 pins in this ribbon, and there's more keys than that, so it's probably a matrix. There may be some clues on this board. We'll probably take some rubbing alcohol and pop off that hot glue so we can just read the silk screen on there. There's another case here where we have a number of buttons. that are running up to this ribbon cable, and maybe they're picking up this button here, this switch, that's also being used for one of the canned songs to play. And then we have the onboard speaker here. Some of the buttons are just built on the main motherboard there, or main board there, so the tempo up, down, and volume up, down. Those are directly on this, what I think is the main button there. So we're just seeing a capacitor and, what is that? Is that an accelerometer or a tilt switch? I don't know if this thing does, I don't think this does any tilt switchy stuff. Let me look at the, yeah, I won't look at the manual. Is that a fuse? Someone tell me what they think that might be right there. A little silver cylinder there. What's that likely to be? Fuse? Tilt switch? Temperature? Other? So then we've got the speaker. And so this, I'm going to zoom out just a little bit here. So this is where I've started my modifications. And this is a ground that's at the center of the on-off switch, so that seemed like a convenient place to grab ground. The red wire here that I'm holding, this is the audio output that goes to the speaker. So through whatever processor and amplifier is built onto the board, it's running through this red line, and it was running straight to the speaker. So I went ahead and clipped that, and where you see yellow, this is my additional wire going to the speaker, and then I've just kind of bridged it right now. So if I take that off, now we won't be able to hear anything because there's nothing bridging the speaker. So what I'm adding is, and we'll go look at the circuit. In fact, let's run over here for a second and take a look at what the schematic is. A crystal. Johnny Bergdahl says he thinks that's a crystal. That would make sense. Thank you. All right. So let me pop open this view here. Okay, so here is my fritzing diagram of the circuit. I'm just going to drag it over a little bit. So you can see I've got, ignore the fact that the speaker object I'm using has plus and minus in disagreement between breadboard view and schematic view, so one of them's wrong, one of them's right. But the top of that speaker there, that's going to, we'll say it's going to ground. So I don't care about that one. This other one is the positive, and that would be like an audio ground, but that part doesn't matter. But the next one here, this is the board's amplifier out that goes to the speaker. So what I'm doing is I'm running that to, zoom in here, I'm running that to a switch. And originally that came from, I just made a mystery object that you can see there in fritzing. I'm calling it the Meowzic audio. And, oops, sorry, it's blank in the screen there. So the Meowzic audio there is just a mystery component that I made, and I'm saying that this pin 2 here, that's where the audio comes out of the Meowzic's amplifier. So that runs to a switch. So that switch can either just be shorted over to the speaker, and then it's going to act as normal, or I can short that over to what is going to be my line out 1/4 inch instrument guitar style line out output. We'll briefly touch on this. I haven't done this part yet, but I'm pretending that there's a couple of lines here for the microphone, and that I'll probably interrupt one of those lines with a switch, and then this is the microphone object down here. So I haven't done that yet, but if I do end up wanting to throw a switch in, that's kind of what it would look like, I think. So here is kind of the interesting part of the whole circuit. And I'll show you, I got this example off of an Instructables post, and then I kind of verified it with some other sources, checked in with Toddbot about it. He said, yep, these values look good. So I put it together on a breadboard, worked out. So what's going on? When I switch my switch, and I'm going to use a sort of low force guitar pedal sort of stomp switch type of switch, because it's a nice big clicky switch. It's not too hard to press like you may think of a traditional guitar pedal switch as you got to kind of step on it. This one's actually easy to click. and it's a nice form factor for something like this on a kid's toy, I think. So click that. What it's going to do, it's going to short the, it's going to create the contact from the Meowzic audio output that was going to the speaker. That's going to run to a 100K resistor. And this is to limit the current so that we don't cause any issues if we short something with the rest of the Meowzic, when the guitar plug goes in, for example. So this will reduce the current. Then we run that output from the Meowzic's amplifier circuit into one leg of a potentiometer. Other side of it goes to ground, and that means I can adjust the voltage of the output audio. So we can basically use like a volume knob of the output, a mixing knob of the output. So I can drop it all the way down, nothing will come through, and then bring it up to something that works with whatever equipment you're sending it out to. So the wiper, that variable resistance value that's changing as we turn the knob, that goes through a capacitor, which is going to, it's a 10 microfarad capacitor. That will bring us to a 0 point. It will remove the DC offset essentially and bring our 0 point of audio to 0. So the baseline of what that audio signal is wrapped around, this will offset it so that we're starting at 0, which is a healthy place. We will sound good when we output this to other equipment. That then runs to a tip of an audio output jack, which is usually the left side, or if it's a mono jack, the only side. I happen to have a diagram schematic here for a stereo one, so I'm just leaving the right ring side unconnected. And actually, the one I grabbed happens to be stereo, and it's the same thing. I'm just not worried about what's connected into that. I don't have anything plugged into that right side. And then sleeve goes to ground. So what this looks like on the breadboard might help. So you can see this one with a question mark. That's my Meowzic's amplifier circuit. The white leg, that wire coming from the middle leg, is going to my switch, which then can, if I send the switch left, then we'll go to the speaker there. Actually, I don't need this wire here. That's kind of wrong. All right, I'll leave it there for now. The other side, when we flip it, means we're going to go through our 100K resistor into the potentiometer. You can see the other side of the potentiometers and ground actually have these kind of backwards. I won't flip them now because the schematic will get mad at me. So this volume would be lowest to the right and highest to the left with the way I have this here, but I didn't do it that way on the one we're going to take a look at. And then you can see the center leg of that runs out to my capacitor to remove the DC offset, and then that goes to the tip of my audio jack, and then ground goes to ground. And then you can see here I was starting to think about the microphone there. So let's take a look at what this looks like in practice. I put this together so that it's sort of modular and we can kind of plug things in and see it come together. Makes it easier for me to iterate on it a bit. I could change out some of the values on some of the stuff. Oops, I got the wrong view over here. Get that out of the way. And there we go. And then we'll also mount it into the case, I think. Maybe we'll mount it into the case today if we have time. So first thing is our switch. So this, zoom down in a bit. This is the switch that is going to say either this heads to the speaker or it heads to the rest of the circuit to go to our video output or our audio output. So I've used some color coding and some heat shrink here so that I don't screw things up. But I've got essentially a pair of wires that are, the audio input is this red line here, so that's in the middle. These switches are essentially a three-pole double throw. So there happens to be 3 poles, one of them broke off, but they're all double throw. So there's something common in the middle that is either going to be sent to that side or that side, depending on the position of clicking this. It goes between one another, flipping back and forth. So I'm going to plug in this yellow line here is what's going to the speaker, and this red line is what's coming from the Meowzic's audio board. So that means right now, with just this connected, in one position, we should hear audio come out of the Meowzic's built-in speaker if it's turned on. So I'm going to turn it on. Okay, and I'm not hearing anything, so that should mean that if I click this, you're in the on position. Okay, that's good. Have I already broken it? Check my batteries. I'm going to just assume the battery's okay. So let me, oh, I plugged the wrong thing in, even though I color-coded it. I'm sure someone saw that in the chat, sorry. There we go, here we go. Oh, we got the drum going, all right. That button likes to get pressed, so, okay. Here's, all right, so here's the demo of just that. Okay, so it's either going to the speaker, or I click it and now it's going down that blue line. So that's just taking the audio and diverting it either to the speaker or to the rest of the circuit. So let's see, now what I've got is this little board, and you could dead bug, airwire, all this stuff. It's pretty typical to do it that way. If you look at the Instructable that I'll show you in a second, that's how they did it. But for me, just to make it really clear, I put it on a little proto board here. And so what I'll do is then run the switch output that goes to the rest of the circuit. It's that blue line right there. What's happening on here is everything I described about going from the audio of the Meowzic through the switch to the resistor. Then we go to one leg of a potentiometer that I have there. We have a ground for the potentiometer. And we have the other side running out to the capacitor. And then the capacitor output is this yellow line that'll go to my audio jack, and then we have a ground there for the audio jack. So that means if I take potentiometer here, and let me be a little more careful about my color coding there, plug in those 3 cables like so. Okay, that'll now allow me to adjust the audio voltage level, volume essentially. And then here is my jack. Like I said, I accidentally grabbed a stereo one. It still works fine. It just means that there's one lug there that's for the ring that I don't need to use. So I have the tip and the sleeve there, and I will plug those into the output. And then the last thing that I need to plug in is my ground. That's why I confused myself. Okay, so there we go. This, I put some extensions in here. So this is the audio. And ground, and then running to the switch. I sort of left that extension out of there. Okay. So this now, if I zoom out a little bit, sorry about the close-up there. So hopefully this now makes sense. I've got audio from the Meowzic goes to center of this switch, and then those run either back to the speaker or out to the resistor, which then goes to one side of my potentiometer. I've got ground on the other side, and then the output from that goes through this capacitor and out to this jack. Okay, so first thing we'll do is just see, does it still work with the speaker side of it. It's playing a song. Oh, I don't want to play those. Stop, stop. Okay, so that works. Oh geez, it's so easy to accidentally stop. So now what I'll do is I'm just going to hang this stuff out the edge here. Turn it around. And zoom out a bunch. Okay, so this was just the jumper I was using when all of this wasn't there so that the speaker would still run, so I don't need that. So there's what we have. And that means I can now plug in a guitar amp. So let's go straight to an amp. First of all, this will just give us some volume. So I have a 1/4 inch jack, and I'm running to this little sort of guitar amp thing here. Okay, it's going to hum and buzz when I touch it, but it should be pretty clean when I'm not. So, okay, so there's built-in speaker. I'll lower my volume a bit. I'll stomp my switch. Get some. Hold on, something seems a little loose. Now, ultimately, this is. I'm going to do straight wires. I'm not going to. I'm going to run wires that are soldered on both ends and not use all of these jumpers because they're going to introduce noise and problems. So this is kind of more just in testing. Yeah, I can tell something is a little loose. Oh.
Meow. Meow, meow, meow.
Oh boy. Oh boy. Sorry about that.
Meow, meow.
Yeah, something I've got flaky here. I think it's just a jumper, one of these jumper connections. I'm going to start one of the drum beats playing so that I can diagnose this. That's better. Okay, so I won't touch anything here now, just because I'm sure I've got some loose connections that aren't healthy to touch. But so what this means, though, is we can now, with a clean signal come out of this, go into a guitar pedal, which is kind of the point in making this sound good. So it's cute, but it doesn't sound great. My hope is we can get it to sound great by running it into this delay. So let's carefully try to not disturb too much. And I'm going to add this delay pedal into the mix. Get this up so you can see in the camera a little better. Okay, so I forgot to get some longer patch cables. I've just got some of these real short ones. So I'm going to go into this delay pedal that C. Grover will recognize, because it was his, and out to the amp. And now we should get cool delay. And we can adjust things like the speed of the delay, type of delay, and the effect entirely. We can also get, oh, you can hear that mic, right? That's why I'm getting all that feedback, by the way. Right, so that's why I think now that we have an external speaker, there was no danger of that little speaker feeding back with this, really. You can hear it even when I'm speaking, I'm getting this feedback. Not as bad when you're playing, you won't hear it as much, but that's, this should go as far away as possible. So the other one I have here is going to be bonkers, but this is a distortion type of pedal. All the cool pedals, by the way, my son took with him to college. So I don't have any of the really, other than this one actually, this is the only very cool one that he didn't take, probably for size reasons. But he did leave this one little distortion pocket metal. So let's see, I'm going to turn that down. This is not as pleasant as this Giga delay. I love the delay on there, and you could get a lot with delays and reverbs. But here's the pocket metal, which should just add a lot of distortion. Here it is clean. Just likes the feedback, sorry. Yeah, I really feel like we gotta cut that mic out of that. So anyway, that's some of the, yeah, can I turn off the mic? So let's do it. I think that's a fun activity. So let's just see what's the clean way to cut the mic out of this. Later I can add a switch, but if we look in here, this is mic running to the board. And I'm going to get some rubbing alcohol and a little pick. And actually this works, let me zoom in here. This works fairly well I find you can just soak a little rubbing alcohol onto a little tool, screwdriver or other. Just drip it and pry on the blob of hot glue. They kind of worked it all over the wiring there, so I'll take a little more. There we go, so that helps. And now I'm just going to desolder one side of the mic here. There's a kind of white, grayish, and a black. So I'm just going to desolder the black side of that. Question is, do I have the right wire for my soldering iron? This is the one that likes to shut off pretty quickly, so we'll see if we can low voltage, it says. Darn you. All right, I'm gonna just ask it nicely. Please heat up enough to just, no, darn it. All right, let me grab a different wire. Oh, here's a new one. Let's see how this one does. How about you? Yeah, there we go. We're getting some temperature on that. There we go. So mic should be disabled now. And I'm just going to live dangerously and leave that off to the side and hope it doesn't magically re-short itself. Okay, so now if we try this distortion pedal. Okay, good. Power to the pedal. Oh, I had to make a inversion of polarity for the power supply that I'm using here on the pedal, because pedals are center negative. And so I've got essentially center positive to center negative here with this little set of adapters. Okay, I hear. Okay, so this pedal has like a tone knob. Let me turn the volume low. So you can see it kind of cuts out some of the high end, like a little filter. So we'll keep it pretty high end and then start adding in distortion. Something, by the way, is noisy in my, I don't think it's just that pedal. Could be, I wish I were running this off of a battery, but let's go back to the giga delay there for a second. The feedback is gone though, so I'm not getting that mic feedback, which, whew, that's great. So let's see, I just want to see if this signal is still clean. Because I think I've got some wiring to clean up there. Yeah, it's real noisy. All right, so let me... Let me wiggle things and see if that... I think it's this potentiometer is suspicious. That's a little less noisy. All right. Well, I'm not a keyboardist, but I do like to have fun with pedals. So that is it. That's going to show us how to get line out from this and pretty much most toys. You may need to do a little bit of figuring of the values on the resistor and the capacitor, but otherwise most toys that have a speaker out, this is a pretty solid way to both switch from the toy on its own and then out to other equipment, which gives you amplifiers and pedals and delays and loopers and things like that at your disposal, which is pretty cool. Same with Eurorack. When I was testing this, I had this running through into my Eurorack. The fact that we can adjust the level with this volume knob here, you can hear. I think this is broken. I think something's going on with that knob, which is where anytime I touch it, that's where I'm getting a lot of the noise, and it's not working to change the volume the way it was before. Yeah, that should be totally dropping the volume to nothing. So I've got some troubleshooting to do there. No, I shouldn't make any sound when it's far left like that. So let's unplug that stuff and take a look real quick at what else is in here. This one turns off if you unplug the input, which is nice. And the other thing I'll do is, I think I won't do this right now because I want to troubleshoot the circuit before I commit to placement. But what I'm thinking with this is to put this switch maybe on the top of this ear, so you can click that up and down there. Put a volume knob maybe there. Get a nice little knob cap on there. Looks like his tiny little hat. Oh, maybe I'll put it there. It looked like a tiny little fascinator. How cute is that? Yeah, that's what he needs. And then the line out will go maybe over here, but there's tons and tons of room to place stuff in here. So I'm not going to take all of it apart, but the thing I did want to do is just pull up this board to have a look at it. And also Lamore said, hey, if you take that board up, give me a picture of it so she can take a look at that from a... by the way, they put in this packing tape just to kind of keep the wiring, I'm assuming keep the wiring in place while they close it. I think that's just a in the factory thing. I don't think these aren't going anywhere in use. So I suspect they just put this light packing tape in here to make closing it up easier without things getting pinched, I suspect. So if we take, I'm just going to flip this around so I can look at it. A driver. There's a couple screws here. Let me turn this off. What, 3 screws? Yeah. And pretty much everything runs to this, so that's how we can guess that this is where the brains are. Assumption is that we're going to find mostly epoxy blobs. And so far, all of the exterior screws were the same length, and it looks like these 3 are the same length and size, which is nice from an organizational standpoint. Okay, so let's remove that and see what's holding you back. That and this ground are a little tight. Okay, so I'll try to orient this to the camera. Okay, so you can see we've got main microcontroller there. Try to get a good focus. Under an epoxy blob, so not much you can do with it. You can see a lot of solder joints here where all the ribbon cables come in from all of the buttons and the button matrix. Some passives, some bigger capacitors for probably the audio amplification and filtering. There's 4 button. Could probably lift one of these up. How do they have those on there? Is that, yeah, these are all just little nubs that pull through there. So same sort of video game controller pad type of pair of contacts there that are shorted by the nub, the rubber nub. And that's about it. So not a ton to look at. And then I think all of the other boards here are going to be just button boards, is my guess. So I'll end up pulling those up, but this is going to have, you know, one switch here that you can see there's 2 wires running to that just plays that one sound effect, the start stop and so on. So that's it. That's the tour of the Meowzic interior. Not a lot to see. I think since there are a decent number of passives, resistors in particular, and since I've seen that people have circuit bent this, that some of this probably timing, maybe that crystal is what someone is messing with when they're doing some of the pitch shifting kind of stuff. I'm not sure, but that might be fun to probe around with and see how circuit bendable it is. But I think that's going to do it. Sorry about some of the noise, feedback in particular, but also some of the noise in my circuit there. It was clean and then it wasn't, so I think using the jumper cables makes it a little easier to test some stuff at first, but I suspect that every one of those connections there is suspicious versus running straight runs of soldered wire. So that's what I'll do ultimately when I mount this up. All right, so I think that's it for the Meowzic. Let me see if anyone has thoughts and questions. Looks like there's in the comments over in Discord, Axwax hacked a kid's toy here, added in a Pro Micro and a DF player, very cool, to the button matrix. So complete takeover, I love that. Let's see. Thoughts, questions. C. Grover says it could put a strap on there to do a kiddie guitar. I need both guitar and keyboard lessons then. Yeah, so I agree with everyone. Sorry I didn't cut the mic off earlier, and that does need a switch for that. I think a little external switch to cut the mic. Unless you're a big fan of feedback, and then just shove that mic right into the amplifier, and you don't need anything else. All right. Before I go, I'll remind you, you can get yourself a discount over in the store. Happy Day, Happy-Day, 10% off over in the Adafruit store. Head on over there, find some stuff you like, and get a discount on it. That is going to do it for Adafruit Industries. I'm John Park. This has been John Park's Workshop. Thanks so much for stopping by, everyone, and I will see you next time. Bye-bye.